tower crane is a machine equipped with a hoist rope, chains or sheaves, and used to lower, lift, and move heavy or bulk construction materials around. The task is to create a tower crane taller than 35 cm with toothpicks and hot glue that can maintain a load of more than 50 grams in equilibrium. You must determine how much and where your counterweight is placed on maintaining the balance of the crane. You keep increasing your load by 50 grams until your crane falls out of equilibrium.
Hello everyone, this is Gabby. Welcome to my channel. Today I'm going to talk about engineering mechanics. To discuss the details of engineering mechanics, we need to know two important terms, vector and scalar. A scalar quantity is a physical quantity with only magnitudes, such as mass and electric charge. On the other hand, a vector quantity is a physical quantity that has both magnitudes and directions, like force and weight. The other two important terms are forces and equilibrium. Forces are the push or pull on an object with mass that causes it to change its velocity. Force can be either an internal or external agent capable of changing a body's state of rest or motion. It has a magnitude and a direction. Equilibrium. Newton's first law states that as long as the sum of forces acting on the body is zero, the structure is in equilibrium. To solve the problems of the statics, it's important to know what is a free body diagram. A free body diagram is a drawing of a part of a complete system, isolated in order to determine the forces acting on the rigid body. Let's look at the simple question of equilibrium. Two people, A and B, are holding a 5 kg object between them using tables. How much force does each of them have to exert to keep the object in equilibrium? First of all, we need to draw a free body diagram of this question. The sum of force in the x and y directions must equal 0 to keep balance. Imagine there are two invisible triangles in the diagram. This line is the tension of B in x direction, or Bx, and this line is the tension of B in y direction, or By. You can get the tension of B in x direction by TB times adjacent side divided by hypotenuse, or TBx equals TB cosine 10D. The tension of B in the y direction can be solved by TB times opposite side divided by hypotenuse, or TBy equals TB sine 10D. Plug this equation in, and you'll get this equation. The sum of force in the y direction equals the sum of the force of A and B in the y direction minus the force of gravity, and the whole thing equals 0. Plug the numbers in, and you get this equation. We know that the force of x on both sides is equal, so we get this equation. Plug this into the equation above. Move the numbers to the left side and rearrange the equation. Finally, solve for TA. Plug the value of TA into the equation and you get TB. Ta-da! Now you get the answer to the first question. Now think about a wrench and nut, children on a seesaw, or a door open around a fixed hinge. All these things are connected to something called moment. A moment is a turning force around a fixed pivot. The nut, the middle of the seesaw, or the hinge are examples of the moment. If something is balanced, the moments are equal and opposite on both sides. Take the following question as an example. Consider the seesaw below. Child A weighs 20 kilograms and child B weighs 14 kilograms. How much force must the support exert to keep it in equilibrium? If child B sits 5 meters from the support, how far away should child A sit from the support? Because the seesaw is in equilibrium, the sum of force in the y direction should equal 0. The force of the support should be equal to the force of child A and child B. That way, we get our first equation. It's important to know that the force is calculated by 9.81 newtons times the object's weight in kilograms. From the step above, we get Fs equals Fa plus Fb. Plug the numbers given in the question and we get the answer to the first half of the question. That is, the force of support equals 333 newtons. The moment of a force is determined by force times perpendicular distance, or m equals Fd. The moment of both sides should be equal, which means the heavier child should sit closer to the middle of the seesaw than the lighter child to keep the structure balanced. The sum of the moment of the support in the y direction equals the moment of force A times its distance from the support minus force B times the distance from the support, and it equals 0. We put our target variable on the left side of the equation, plug the numbers in, and got the answer to the second half of the question. That is, the distance of child A from the support is 3.5 meters. This is the end of the video. I hope you like it, and I look forward to seeing you in the next one.